Video, I'm going to be explaining the intransitive or non-transitive dice, which were invented by the mathematician Bradley Efron in the early 1900s. So I first discovered these non-transitive dice in the Elements of Mathematics EMF 08 probability course. But I actually, the AoPs summer class, Math Beast Camp, in the last week, they mentioned this non-transitive dice in the class again. So it's kind of like the two curriculums mentioned the same thing, so we went over that in the class as well. Okay, so say you have a die, it's a 6-sided die, but unlike a normal die, it's not labeled 1 to 6. So you have 6 faces, but all of them are like weird numbers. You're not going to find this on a normal die. So you have 6, 8, 8, 9, 8, 7. So the probability of each one is 1/6. But, as you can see, there are 3 8s here, which means you have a total 1/2 probability of getting an 8. So that's actually quite a high probability. So you're most likely to get an 8 on this die, although it is probably likely that you could get a 6, 9, or 7. Let's call this die A. And then for B, let's say you have 5, 6, 5, 6, 5, 6, something like that. So you have an equal chance of getting a 5 or a 6. So let's say 1/2 of 5, 1/2 of 6. This is die B. Okay, and then for die C, let's say 1, 2, 1, 2, 1, 2. Okay. And again, you have a 1/2 chance of getting a 1 and a 1/2 chance of getting a 2. So, this is die C. So looking at this here, it's probably, if you roll all 3 dice and you take the sum of their values, you're probably going to find that most of the sum comes from die A, because you have a 1/2 probability of getting an 8, and the 6, 9, and 7 here are all either greater than or equal to the possible outcomes for B and C, which means that if you roll die A, you're most likely going to get a higher sum on this die than you would if you rolled B or C. And also, if you roll die B, you're also going to get a higher sum than if you rolled die C. Because die B, you can either roll a 5 or a 6. But these are both lower than the sums you could get on A. And then over here, for die E, 1 and 2 are both lower than the sums you could get on die B or die A. So it makes sense that die A and die B would give you the higher value 100% of the time, because it's literally impossible to roll any value that is lower than any of the values on B or C on A. And it's literally impossible to roll any values that are lower than the ones on C on B. So if you roll die A, you have 100% chance that the value is going to be higher than B. And then same, it's going to be 100% chance if you roll B, that's going to be higher than C. So if you play a game that involves 3 non-transitive dice, then you have to make sure you choose the right one. For example, if your opponent chooses die B, and if you have the choice between choosing die A and die C, you obviously should choose die A, because you'd always get the higher roll. And if your opponent chooses die A, you know you're going to be doomed, because you have no choice of winning, because the die B and die C are all have no values higher than A. So you always know with non-transitive dice if you're going to be winning or not. So that's the kind of the thing with these dice. All right, and that's it for this video.